So, my name is Martha Gulman, and as Luke said, I'm here to talk to you about atomic orbitals. And many people don't think that they're very interesting, and very much like botany, it's like the bum of the jokes of all of chemistry, because they're apparently the least interesting and apparently the hardest, but they're actually like core to everything. And you can also explain them with balloons. So, and the reason that I'm interested in them, because I think if you don't understand why atomic orbitals occur and how atoms actually exist in space, you just can't understand any form of chemistry. And it's really, really vital, and it's really cool. But so before I do that, I want to start talking about atoms, which are the smallest particle that you can get, or the smallest thing that you can get. And everything around us is made of particles, like yourself and your drink and the floor and the tent and the bunting and me and you. And everything is different. It's a different arrangement of atoms. And atoms aren't like little spheres. Instead, they're actually made up of other things, like so. So atoms have a little core to them, like a nucleus, and then outwards come the electrons. So in the core you have the protons and the neutrons, and they don't really do anything, they just sit there, so I'm not going to talk about them. But what I'm going to talk about is the electron, the little blue dot there, which I think is the coolest subatomic particle, hence the balloons. So you can explain atoms by comparing it to the solar system. You can say that the nucleus is the sun, and the electrons are orbiting the nucleus the way the planets orbit the sun. But that's actually not true. So the reason for that is because when you think of the solar system, you know where each planet is at every given moment. You know where it was, you know where it will be, because planets walk around, they go in certain paths. But electrons can't do that because they're wild and free like me. So electrons, you cannot know where the electron is at any given time. You cannot know where it was, nor where it will be. You cannot trace its path of movement. It's so tiny. Like, think about it. How would you detect it? You don't know where it is. So that's called the Heisenberg uncertainty principle. And that was a problem for a while, because this is the most basic junior cert level diagram you can get, and everyone thought it was true, and then everyone thought that was wrong, and then everyone thought they didn't know what to do. So they shook their head around a little bit, and they came up with a different theory, which is the atomic orbital theory. So if you consider the nucleus, and if you consider all these electrons that are zooming past it, they don't do that just randomly, they do it in shapes. So the new definition of an atomic orbital is not like the planetary orbital, it's a probability function. So you know the space the electron may be in, you just don't know its exact position in that space, but you know the space, that's something, hence the balloons. So the first orbital that you can get around the nucleus is called the s orbital. It's spherical and it's the smallest one, like so, and this is deflating. It's still winking though, it's fine. So it's spherical and can be described with one single balloon. But if you have more electrons, like the bigger atoms, you have to put those electrons somewhere else. So this can only hold 2. That's a bit useless. So if you consider, if the atom has more electrons, where do they go? They can't fit where the 2 go, so they go into these lobes. With each lobe carries an electron. So if you think nucleus, another sphere, and then you have the p's, the px, the py, and the pz. And if you put them all together, you get this really cool shape. And the smileys aren't actually in an atom, but we'll pretend they are. So you get this really cool shape like so. And you can see that that's not like an elliptical path at all. It's actually a shape. But if I'm to keep going, because orbitals exist indefinitely, and you can span the whole of the alphabet trying to describe them. So if I were to keep going to attempt to describe what orbitals are to you with balloons, I'd have to open a balloon shop, and also I'd have to grow more arms and legs and octopus around a little bit. So instead, I want to finish an example. Oh yeah, and also these are the D's and the F's, so you can see I can't do that, I'm sorry. But I'm here to illustrate it. So instead, I want to finish an example. No. Yes. So my example is hydrogen. It is the smallest atom of all, and it only has 1 electron. So 1 proton, 1 neutron, 1 electron. So it just has the s orbital. So it just has the s orbital that zooms by it. But if you put 2 hydrogen atoms together, you get something that's called H2, and it can be described like so, which 2 spheres that come together. two spheres that come together. Next up, but what happens when two hydrogen atoms actually come together? What happens when hydrogen atoms actually come together? Like so. You get what's called hydrogen gas. And does anyone know what hydrogen gas is? It ends with a big bang. Thank you.